my memory serves me right. And even Philemon Masha. Is that true or false? Philemon?
Yes.
Philemon ulikuweko jana?
No.
And Abuga? And Turanira Murume, were you there yesterday? Hmm? Turanira? Anybody who can see Turanira for me?
Yes, I can hear you.
Were you there yesterday?
I wasn't. I'm repeating hydraulics 1B.
Okay.
Yes.
Make sure you make it, eh?
Okay.
Okay, sawa. What of Boris Yeltsin? Boris Yeltsin, were you there?
No, sir.
Yeah. My memory shows that you are not there. You have come in today.
Oh, I'm also repeating.
Na nimesema karibu basi. Sioni mzuri?
Yes.
Thank you so much. Feel at home. Relax. Joel Turanira. Thank you, Joel. I schooled in Meru, so I know who Murume is and Mukuru. And Joel. Okay, then karibuni sana. And let's pick up our discourse from where we had stopped. We had given ourselves an introduction to the course unit 32321B. And in it, we said we deal with rotodynamic pumps and positive displacement pumps in general. Under rotor, you come across centrifugal, reciprocal, and other types of pumps. Either axial flow, mixed flow, or radial flow, and others which may fall under that classification. We also have what we call borehole submersible pumps. Maybe this time I'll bring them out also, because they are part of reciprocating pumps, but multi-stage. You can have a reciprocating pump which is single stage, you have multi-stage, you may have double stage. Sometimes you may give them a description depending on the mode of installation. Sometimes we end up having what we call turbine pumps, but falling under the classification of centrifugal pumps. Turbine pumps are very rare. We used to have one in Gilgil military barracks. I don't know whether they still have it. When I was in the industry, niliwashughulikia sana. That was Gilgil 5KR, Kenyatta Barracks, Support Battalion. I don't know that it's still Kenyatta Barracks, and also the livestock area, that place. So things I've been able to do when I was at your age. And I was not bribed. That's why I'm poor. Anyway. And then we have what we call reciprocating pumps or positive displacement pumps. I came across two of them which are unique. One of them, I came across it in Naivasha, sewerage treatment works, what we call screw pumps. Very nice thing to have a look at. If some of you still visit the library, I don't know whether you still go to the university library, have a look at wastewater engineering, I think. I don't know, there's wastewater engineering by J.B. White. Wastewater engineering by J.B. White. It's a very small book. In the days when man used to have value, it used to be very expensive. I don't know whether it is still available because internet has brought a lot of things. But even those days, when some of us were still students, it was going for 760. That was a lot of money then. Ilikuwa mshahara ya mtu. I don't know how much today it can cost. Though people have been able to use cheaper material, but if you get the original from UK, it can be very expensive. Very, very expensive. I remember there's a day I bought a book for 25,000. I don't know that was 25 or 16,000, but that was for a medical student. Anyway, engineering is not cheap. And once you're able to go through, you enjoy the benefits. Otherwise, I was able to introduce you the cause units, pumps and turbines. And what we are going to go through that, I said I'll share the notes. Once I'm able to go through the first phase of this introduction, I'll always make sure you get the notes so you don't have to panic. Okay? I also said my notes, there's no definite book or reference book you can say I'm relying on this. Sometimes we go out of our way to put in what we had from the industry through experience and through interactions for us to be able to talk about some of these things. We talk out of theories, we talk out of practice. Carlos ameingia mwenyewe. We talk out of theory, we talk out of practice, what we have been exposed to, and the little things we normally do here and there. All these things put together. We were able to define what a pump is, and I think we came up with a clear dichotomy, if I may use that word, or the clear difference or separation line between a pump and a turbine. Under that, we'll look at the various types of pumps in detail, and that is what we are trying to do. First and foremost, let me zero on rotodynamics or rotodynamic pumps, which basically are centrifugal pumps. Special effect pumps. The day I will talk about them, maybe you'll get an assignment out of it so that you can be able to find out by yourself what these special effect pumps are all about. Or if I feel generous, I will give you some of the special effect pumps. Because, like I told you, you are not training for Kenya. You are a global worker or laborer for that matter. You never know where fate may land you. And you come across some of these things. There's a time I had to assist one of my students because he was going to head a program in Bangladesh. Tangu aende Bangladesh, sijawahi kumsikia tena. Maybe money became too much and we diminished in his memory. Otherwise, let me admit Kina Muridhi, John, George Lundi, and I don't know why Lundi is trying to, I don't know whether he's checking it twice or he's coming in for the first time, but I know he was there last time. So I was saying, you never know where fate may land you. And you need an exposure to some of these things because civil engineers cut across the globe. Okay? They cut across. I think Bisogan, I had him yesterday. Cut across the globe besides where fate may ever land you. You may even find yourself in Russia, okay, or Mongolia. I know you may think some of those countries are too remote or remotely placed, such that you may have no interest with them. But I remember one of the programs we were writing some time back, looking for funding. We had to use the Mongolian experience and what the Mongols are doing so that we could be able to couple it with what we wanted to give to Kenya. Okay? It was a very nice program. It brought the university 1 million euros, they call them euros. I didn't get much out of it, but it's okay. I liked what I did. Otherwise, we're looking at the various types on a broad sense. Okay, those ones with a piston, with a single rotor rather, with multiple rotor, like the gear pumps and the log pumps, which I did say that some of them were available in Kenya when we used to be the blue-eyed boys of the donor community, until we started misbehaving. Most of them withdrew. Companies like Hards and Bell, which used to make some of the special effect pumps, went away. Wigos went away. I'm sure Josansen and Soen may not be in Kenya unless they changed their business. And the whole market, you cannot imagine, was left to Davis and Shatlips and Rift Valley Machineries. And to a small extent, I don't know whether they still do that, because they used to be Gill and Roberts, but they became Mantrack. You get hard moving machines. Not only that, you get hard moving machines, they can give you good generators as a prime mover. And they used to sell pumps. I don't know whether they still do it. Those are companies I was able to interact with when I used to be in charge of tenders. Tendering and tender advertisement and procurement to some degree. Okay? These are things I liked doing when I was young, like you, until I came to teach. When I started teaching, I did start a little bit. And I think now I'm doing it for you guys as we learn. And I think this is a good idea. Otherwise, back to rotodynamic pumps, which I said we start with, where in this case, we said that these pumps are quite unique because Michoya is coming in. These pumps are quite unique because they have a rotating element in themselves, which we refer to as the impeller. I'm sure in your physics, you must have come across what we call centripetal and centrifugal forces. They come into play when you are running your impellers inside a casing so that you can be able to impart energy into the liquid. And this energy which is imparted into the liquid is converted into pressure energy. And therefore, you can be able to raise the liquid from a low level to a higher level. Okay? That's why sometimes we say that the rotodynamic machines or pumps, they are in a class of what we call turbo machines, whereby there is or they impart a change of momentum in a fluid which is moving. Sometimes we go to the extent of having compressors, I think, and some small machines in the houses for cooling. You may find they are falling under this kind of a category of turbo machines, if I may say that. Though when you are dealing with them, we give it a different kind of an approach. Okay? In buildings also, we do install these pumps. Under what circumstances? Under the circumstances of firefighting. In buildings, we have what we call riser system. Okay? Where you have a system of firefighting, but it remains dry with no water for firefighting. Until when the machines that sense, the sensors, maybe sense some kind of smoke, because we have smoke detectors. They detect smoke, and the interpretation is that the building is burning. Then the machines can turn on and find they're spraying water all over to quench or to extinguish the fires. That is for a dry riser. We also have what we call the wet riser system. Okay? The wet riser, the systems are fully charged with water, so that when there is smoke detection, because in buildings we design them, we construct them and put smoke detectors. Then the thing will turn on and they spray the liquid all over to make sure that fire is extinguished. So there is more to it than just pumping water for drinking. Sometimes you need a booster pump also, because you can imagine like a building like the Times Tower, KRA Tower, or Times Tower. You can imagine a building like the KICC and those ones which have come up on Upper Hill. These buildings need systems for their day-to-day maintenance, and in case of fire outbreaks, okay, or for the sake of running the facilities, because they have toilets, they have kitchenettes in some of the offices. People also drink water. Sometimes you need to wash some of the floors. Some of them have incorporation of flowers in pots and things like that. So you need water to the highest point in some of these buildings. And because the county government of Nairobi may not have towers that are elevated high enough to supply by gravity, in your building design, you design and you incorporate a booster pump. Though in building construction, we call some of these mechanical services. We have mechanical and electrical services. we make provision for that kind of thing so that in case of anything, you make sure that every floor is well served. Shortage of water has become acute in the city because I remember when we were students, Nairobi used to have a demand of 33 million gallons per day when the supply was given 29 million gallons. I'm sure it is now worse than then, because that can be told by those who live in some of the estates. They rarely get water from the county government or the Nairobi Water Company, whatever it is, okay? Unless they have gone sinking boreholes in some of the estates. But sometimes you find you sink them at your own risk because we have a high degree of pollution with some of the systems for transmitting sewage. You may dig a borehole, sink a borehole, and then it becomes contaminated. Anyway, these are complexities which maybe with the time, when you start practicing, you'll be able to address them. So, good examples of this, we have the centrifugal pumps, because a centrifugal force is responsible, as I've said, to create that pressure variation in the machine due to the rotation. And therefore, they can be able to raise liquid from a low level to a higher level. These machines have key components you cannot fail to talk about. And if you ever talk about it, these are the components you may have to address and look at them in details, because they speak everything about them, or they address everything about them. Even their performance and efficiencies depends on some of these components. You have impellers, which sometimes we refer to as a rotor. And on the impellers, we have what we call curved vanes, which are responsible for changing or giving direction to the fluid coming in once the pump starts running, okay? Otherwise, it is the impellers which force water into rotation so that it can be discharged to wherever it is required. They also have a casing provided for housing the impellers, and it is out of the casing also we can draw a unique classification where we can have the diffuser type of casing, and the pump which goes with that, we call it a diffuser centrifugal pump. We have what we call a volute kind of a casing, and the pump going with that, we call it a centrifugal, a volute centrifugal kind of a pump. And then we have the vortex, or what we refer to as the whirlpool kind of a casing. Okay? So that's why I'm saying these components are quite key, or these components are quite key, and you need to master them because it is on their basis you come up with their classification. Okay? Because when you tell someone I have a diffuser type, what comes into your mind? What comes into your mind is what the car casing is housing, because it must be housing impellers which are formed, okay, or impellers which are in a certain way or formed in a certain way. Unlike another, if you tell someone it's a volute casing, what comes in my mind is that the impellers also bear a certain shape, and the vanes also. There are some which are facing backwards, and there are some which are facing forward. We'll look at some of those details. Or if you tell me it is a whirlpool thing or vortex, I know what you are talking about and what I'm going to expect inside if I open it. Then we have the suction pipes, where the upper side of it is what delivers from the pump, delivers to wherever the liquid is required. Okay? And it has, or rather, sorry, if it's a suction pipe, it draws from the sump or from wherever the liquid is being drawn from. It is on the suction pipe also, where we expect to come across what we call a voot valve. A voot valve is like a non-return valve. And also there is what we call the strainer unit, because sometimes you find yourself pumping a liquid which is completely full of debris, or you may find yourself pumping sewage. What do you do with that kind of a liquid? And you can imagine the composition of sewage all the way from the entry point at the racks, at the screens, come to the detritus tank, come to other chambers whereby you remove each and everything, even the grit material in that sewage. Okay? So what kind of a pump would you go for in that case? So it must have a voot valve and a strainer unit. There is also the delivery pipe, whereby it takes off from the pump on the upper side so that you can be able to deliver the liquid where it is required. These are key things that you must be able to address. And then there is the delivery valve, which is a non-return valve connected between the pump and the outlet. Okay? And it is right at the lower end of the delivery pipe. Why we have that kind of installation? So that when there's power failure, or in case of power failure, or in case of stoppage, you don't have the liquid running several kilometers from where you are pumping from back to the sample. There shouldn't be that kind of a thing, and that's why we have a non-return valve, which holds the liquid into position even when there's power failure. Then I told you another key thing, which possibly you can have a look at or measure it, are the prime movers. You use them for rotation of the impellers. This could be a diesel engine or diesel generating unit, or it can be an electric motor. And I'm sure in your electrical, at the formative stages, someone must have addressed what we call DC and AC motors. Okay? The other thing is, it is on the prime mover whereby the coupling takes place. Is it direct couple? Is it on a common base plate? Those are the things you ask yourself. Or is it belt coupled? All these kind of arrangements, you meet them in the industry depending on the ground conditions. Okay? Otherwise, in a broad sense, we can talk of what we call axial flow pumps, radial flow pumps, and mixed flow pumps. This still will depend on the action of water when it enters or when it enters into the casing and the way it comes into contact with the impellers. The way it comes into contact with the impellers when it is drawn in will dictate whether it is axial flow or radial flow or a mixed flow pump. All these things you will always come across. Otherwise, that's why, again, on the basis of the impellers, you may have what we call closed impellers or shrouded. You may have impellers which are semi-open, or else you may have impellers which are open. It all depends on the liquid you are handling. It is also on the basis of the impellers. You can talk about whether it is a single stage or a multiple or double stage or multi-stage, several stages. For example, the borehole pumps are multi-stage. They have several stages. If you go to Davis and Shutleaves, you have to tell them what you want to do with maybe a borehole submersible pump. And they'll give you one with maybe 30 stages or 40 stages or 50 stages, depending on the amount of work it is supposed to perform. Okay? These are things you have to have and understand. You have to have clear in your mind and have a clear understanding of what you are looking for. Now, we've done say these centrifugal pumps are the hydraulic machines, which may convert mechanical energy into hydraulic energy. Okay? And then you can be able to raise the liquid. Wherein I've said, or we'll tell ourselves, which is true, that what we refer to as hydraulic energy is a form of pressure energy. Okay? Where what we are calling mechanical energy is converted into pressure energy by use of a centrifugal force. This centrifugal force will act on the liquid or the fluid, and the fluid it will act on can be water, can be a gas, can be some form of a slurry. Because I told you also in the construction industry, we have cases whereby we have to pump concrete. I'm sure your concrete man must have told you that. You have concrete pumping machines which are special, and they could be centrifugal pumps. Okay? Otherwise, it's a pump which is very versatile in that we can be able to put it into many uses. Okay? What many uses? We can use it for pumping water. We can use it in the coffee industry. We can use it in the cement industry. We can use it in construction industry. We can use it in storage projects. We can use those machines also for many other purposes. Even in the car you drive, what you call the water pump is a centrifugal pump. It's a very minute thing, which is a centrifugal pump with like a single vein, okay? So that it can make sure water is circulating in the engine for cooling. If you have ever done the theory of cooling, the cooling system in a car, there is always a pump which is attached to it. And not chances, some of them are actually centrifugal pumps. Now, because of the liquids they're handling, they are not of the same quality. I'm sure in your public health engineering, someone must have told you that, for example, water has a pH, and pH, that is the hydrogen, I don't know, ion concentration or something like that, with a range between 0 to 14. 7 is neutral, above 7 the water is alkaline, and below 7 it tends to be acidic. On the basis of that, you make a choice of the centrifugal pump, the impellers, because if the water or the liquid is too acidic and the material for the impellers is one which cannot be able to resist the action of acids, then my friend, you'll be in for a shock of your life. Okay? Another dimension has also come in recently, where you find in parts of the Rift Valley, because Rift Valley is highly volcanic. And some of these companies are coming up with impellers which are plastic. You may have to specifically say or specify and say, for the company which is supplying, I need a machine with impellers which are made of this material. Because like in Rift Valley, some of the wells or boreholes, they have a temperature over 50 degrees Celsius, tending to 100. So if you have a plastic kind of a pump, will you go for, or if you have a plastic kind of impellers, will you install it in such a borehole? I remember one time in Kabarak, we had a borehole which had about either 60 or 75 degrees Celsius, such that for it to go to Mze's place, the design was such that you take the water through a cooling tower before you can release it to his house. In the Rift Valley Institute of Science and Technology, they have a borehole which has got hot water. You pump directly into the bathrooms, and you don't need a heating system, because what comes in is warm, and you can bath for as many hours as possible. Anyway, these are things that you come across in the Rift Valley. And that's why from your geology, you know some of the areas in the Rift Valley, They still have geysers, like in Lake Bogoria, and that's why there's a high potential for geothermal, because the Menengai crater, which is dormant, they say one day it will wake up. Okay? The whole of Naivasha and parts of the Menengai area, they have a high potential for geothermal because there is a lot of pressure imprisoned, a lot of liquid imprisoned under pressure, and the temperatures are very high. Okay? Because of volcanicity, if I may call it so. So because of this, you may have to make a choice of materials where you avoid a lot of corrosion, or where you expect a lot of corrosion. You may go for stainless steel, or else you may go for bronze. You may go for bronze and cast iron or both, depending on the amount of pH that you expect. That is maybe between 6 and 8. And then you can go for cast iron or steel if the pHs are range between 8 and 14, because that is highly alkaline. Stainless steel up to 3.5 pH, that is too acidic. Okay? And even 3.5 to 6, that is still highly acidic. And I'm sure someone must have told you for drinking water, you normally recommend a pH between 6.5 in the worst scenario, all the way up to 7 point something. I don't know, that's 7.4. And I think up to 7.6, we still can be able to accommodate that within our setup. This is a simple centrifugal pump, which I had shown you. It's a volute chamber. You can see the arrangement of a volute chamber. You can see the red impeller thing, which has got the veins. You can see the fledges. You have done public health engineering, you must have come across pipe fitting, fledges, I don't know, unions, nipples, blah, 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 that kind of thing. It has got fledges for joining the piping system on the suction side and on the delivery side. The manufacturers will give you the arrow, will put an arrow to show the direction of rotation on the pump casing. And then depending on what you want to do, you can make a choice of the pump with so many horsepowers or with so much of power to deliver from point A to point B. Okay, I'll still share this with you. Otherwise, we have seen the main component parts of this, the impeller, the casing, the suction pipe with the foot valve, trainer, and the delivery pipe. And we have mentioned something about the impellers and the casing. Okay, then the suction pipe with the foot valve, we have talked about all that. So we are not going to get into more details on that unless it is necessary when you look at the installation, when we look at the ways of installing some of these components or some of these pumps. Okay? Otherwise, after we have done that, let's look at what we call the working principle. What is the working principle of, or how is the working principle of these machines? The main thinking by many people is that pumps draw water from a sump, or they suck water or liquid from a sump before they can put it in their systems and they deliver it wherever it is required. What I'll surprise you with is that a pump does nothing. A pump does nothing to draw liquid from a sump to its central axis, or to the central axis of the shaft, because the shaft will mark the central point of it, because it is upon the shaft where the impellers are also mounted. Up into the casing, the pump does not do anything to draw the liquid. What is that? What there is that we use the rules of physics, where we say nature abhors a vacuum. And because nature abhors a vacuum, before we can be able to start a pump, we put some kind of a condition or a liquid into the casing. And when we put a liquid in the casing to fill up the casing all the way up to the root valve, that is what we call priming of the pump. We prime it, and then if you are very professional in running it, you must have between the foot valve, no, not the foot valve, but the delivery valve or the non-return valve and the last bit of the delivery pipe, you must have a valve. That valve, you close it completely so that you run the pump when the valve is completely closed. Okay? You run it with no delivery at all. And after you have done that, once you look at the gauge, because there's a pressure gauge installed near the pump. Once you look at the gauge and realize that it has hit the maximum, then you start turning the delivery valve very slowly. You turn it slowly until now it starts delivering the liquid wherever it is required. When you turn it slowly, the gauge will adjust itself up to a point where it will give you the maximum operating pressure, or it will give you the ideal operating pressure. Why do we do this? We do this to ensure that, or to make sure that we don't create a scenario where water will hit the system during delivery with a lot of impact, and there will be a massive pressure surge on the delivery side, which we refer to as water hammer, and it will break the system. That's why we open the valve very slowly, turn it very slowly until it peaks. And from the pressure gauges, you can see it adjust until it settles at its basic operating pressure. And then you deliver the liquid to wherever it is required. That is what you normally do. Now, why do we do priming? Priming is putting a liquid into the suction pipe and the pump casing before you even start the pump. The purpose of it is to drive out all the air in the system. You drive it out completely so that when you start running the pump, it will remove the liquid. It will rotate the liquid we are putting, tend to remove it, and that partial removal will create a partial vacuum, or it will create a vacuum. And because of the atmospheric pressure, depending on where you have installed that pump, because you have to look at the atmospheric pressure. Because of the atmospheric pressure will force the liquid from the sump into the suction pipe or into the strainer, force the foot valve open into the suction pipe, and it will raise up to go and balance that vacuum in the pump casing. When it moves to balance that vacuum in the pump casing, then what happens? What happens is that the liquid will come into contact with that now rotating element, the impeller, and it will impart into it centrifugal force, which is converted into pressure energy or hydraulic energy, pressure energy, and then it will force it through the delivery pipe, forcing the non-return valve open, and then you deliver the liquid to wherever it is going. And that's why when you are doing computations or calculations to determine the size of a pump. Some people would like to include all the way from the sump, that is what we call the suction lift, plus the delivery head, and say that is the total pumping head. Of course, when you take into consideration also the friction losses, some people would like to put that together, and then they say this is now the working head or the pumping head of the pump. But in real sense, the pump does nothing to raise the liquid from the sump into the casing. It depends on the atmospheric pressure. Okay? And that's why when it comes to ordering these pumps from the suppliers or the manufacturers, if there are any, a part of the data that you supply them is the altitude where you are installing that pump. Watakuuliza, where are you installing it? Timboroa, Mount Kenya, Nanyuki, Isiolo, or is it in Mombasa? Or is it in Kisumu? Or is it in Magadi? They will ask you all these kind of questions because you may have to give them the average main sea level, or what we call MSL. Why do you give that? So that they can be guided on the details of installing the suction lift or the suction pipe. Because if you make an error in installing the suction pipe such that it does not meet certain specifications, then you write off the pump through what we call cavitation. It's a very serious thing. Cavitation will affect the pump, pit, or eat up the impellers, and then the pump starts running noisily without delivering any liquid. And that's why we avoid that as much as possible. Though some people don't know that. That's why the installation should be in such a manner that when atmospheric pressure is acting to force the liquid through the strainer, the foot valve, and then into the suction pipe, into the pump, it should not draw with it any amount of air, because the attitude will determine at what level you should be able to put the foot valve, or at what level, or what should be the height of the suction pipe. Because at that point you make a mistake, my friend, you are done with your pump. Because cavitation will take place, and within a short time, maybe a matter of months, the thing will be gone completely. And you can imagine something costing hundreds of thousands being written off within a matter of months. Then the organization will wonder, why should we keep you if you are making such big errors as an engineer and you are not advising adequately how the installation of some of these facilities or some of this equipment should actually be done. Okay? So these are things that you take into consideration. Okay? Now, when a centrifugal pump is working on the principal vortex, remember in your basic introductions, we talked of free vortex, we talked of forced vortex, blah, 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 all that kind of stuff. We talked about it in the initial stages of introduction to fluid mechanics, meaning that when a certain mass of liquid actually gets rotated by the impellers using an external torque, then the rise in pressure head of the rotating liquid will take place, and then you'll be able to move it from one point to another. Regardless of the type of pump, what matters is, depending on the arrangement of the impellers and the vanes, it will give or it will dictate the amount of efficiency that it should be able to give you. Because the volute type and a diffuser type, and even a vortex flow one, which is whirlpool, may not give you the same amount of efficiency because of those detailed arrangements of the vanes on the impellers. Okay. Otherwise, what we may refer to as the pressure rise or the pressure head rise at 10 point on the liquid being rotated is usually proportional to the square of tangential velocity of the liquid at that point. Otherwise, what we are referring to as the pressure head is equals to V squared upon 2G. Okay, that is the tangential velocity of the liquid at that point squared divided by twice the gravitational acceleration. Meaning that at the outlet of the impellers, if you examine them in a way, you find that the radius is more than at the inlet. Okay? And as a result of that,
Excuse me, sir.
yes.
Apologies for interrupting, but we can't see your screen.
Why are you not seeing my screen?
Because you've not shared.
Is it on your side or on my side?
Everyone's side, I guess.
Ah, my friend. Sorry. That is very serious. I know you are eager to see. I can talk about it with my closed eyes anyway, but can you see it now?
Yes, it's clear.
Thank you, lady. Thank you, lady. Kwa nini wengine walinyamaza bila kuona? Oh, they thought it was a nice preamble. Anyway. Usinyamaze. Have the freedom to speak. Sasa nikiwapeleka trip mtaenda kunyamaza, mtauliza maswali. I'll campaign to have money to take on a trip if the money is available. Mtauliza maswali, mtanyamaza tu. Then I'll be afraid to take you out. Victor, should this group go out or remain at home?
Be good, twende sana.
Sasa lakini wakinyamaza, so wataniaibisha. Especially if I get to some of because we need pressure to raise the liquid from the casing up to wherever we require it. And you can imagine the kind of headache people had to grapple with coming up with pumping units all the way from Mombasa to Nairobi for KPC, Kenya Pipeline Corporation, or company. It's corporation or company. Okay? They have several booster stations. And these booster stations need these kind of pumps. So it depends on how they were able to design it and how they were able to come up with. Good enough, it was done when people didn't know money. That was 1978 when some of us were still students, between 77, 78, thereabout, before some of you were even conceptualized. That is when some of us were in high school. And I think the design was very well done. It's only that guys who have been operating these booster stations have become clever because they are siphoning fuel from the system. Nakuta lori zinaenda huko usiku kubeba mafuta inajazwa. So by the time it gets to Nairobi, you find so many thousands of liters are missing. That is not good. Anyway, that's a story when we get this. They will tell us how they normally address that, or they can be able to arrest that. Because you never know where fate may land you. You may find yourself in Kenya Pipeline Company. Okay, where do we use this? Like I've told you, we use them in buildings for pumping general water supply as booster pumps, domestic water supplies. And like I've told you, we also use them in buildings for the firefighting systems, where you have either dry riser or a wet riser, okay? Because I know you are going to learn how to design, but there is much more to it in design than what you do in class. And that's why even installations, besides putting water for fire extinguishing, you may need to use chemicals in the paint, which will make them fire resistant. The building make some of the rooms fire resistant. You may have to have doors also, which are fire resistant for 1 hour, 2 hours, I don't know, 4-hour fire resistant doors and things like that. There's a lot more in building design and construction than what you come across in class. And that's why you should purpose to be a scholar so that you can understand how some of these things are done. I would be surprised if you're a civil engineer and you do not buy for yourself some of the construction books. It is good to buy them. Even Structures and Fabrics is a very rare book. I think that Structures and Fabrics 1 and and I don't think I will ever. Anyway, they are used in some of those industries, manufacturing industries, chemical industries, pharmaceuticals, and even food production. If you go to aerospace engineering also, these pumps are so much into use, depending on what you want to do for them. Okay? They can also be used for what we call cryogenics and refrigerants. It's what we call cooling and refrigeration. In cooling and refrigeration theories and whatever, you may find it is actually the centrifugal pumps or the special effect pumps that are being used. Okay? Talk of the oil industry, like Uganda wants to transport its oil, I don't know, from West Nile all the way to the port of Tanga. They wanted to bring it through Kenya. But our guys went buying every piece of land along the pipeline so that they can be compensated. Wherein I say the government should come up with a policy. If it's a project like that, wherever it cuts through, okay, the government compensates a minimum amount because the pipe is underground or in the ground, okay? But Kenyans were interested because we lost an opportunity because of being greedy. So it can be used in the oil energy or oil industry, let me call it so, for pumping of crude oil, slurry mud. They can also be used in the refineries and power generation plants. There is the Kenya Oil Refinery plant in Mombasa. I've always wanted to go there. And I've always wondered why they don't use it. But instead, they bring in fuel which is refined, which has been refined. Okay? Because the byproduct of this, we used to have the bitumen for road construction. So I don't know whether they did close it down in Changamwe or it is still operational. Sometimes we throw away some good opportunities through the window. Otherwise, this is where you may come across situations where you use some of these pumps. Any questions on that before I move on? Elizabeth, any questions?
No questions.
Okay. Evans Nyongesa.
No questions, sir.
Nani mwenye maswali? Wise man Juki, today you were very early, I liked it. Today became wise, like your name. Juki, are you there? Juki. Ama umeenda tu? Eh? Nani amemwona Njuki? Eh? Kiari, umemwona Njuki? Charles,
Bado.
mwambie wache hiyo tabia, akiingia ongea na sisi. When I talk, unmute your mic